So today we're going to talk about Concept 1, solutions. And this is going to talk to us about what a solution is, what a saturated, unsaturated solution is, and how you can make a solute dissolve better in a solvent. So an aqueous solution, or aqueous, I'm not really sure how to pronounce it, but I'm going to say aqueous. An aqueous solution is water with something dissolved in it. So the prefix aqu, A-Q-U-E, that means water. So anything that is an aqueous solution has water as the solvent, and then something is dissolved in water. So salt water is an aqueous solution because the salt was dissolved in water. And whatever gets dissolved is called the solute, and whatever does the dissolving is the solvent. Usually, water is the solvent, especially if it's an aqueous solution, but there could be different things that are solvents. And so, generally, whatever there is more of is the solvent, and whatever there is less of is the solute. So, again, the solute gets dissolved, and the solvent does the dissolving. Here are some examples of what a solution could look like. So the very first one is lemonade. And so when you make lemonade, you have lemonade powder as your solute because it gets dissolved in the solvent, which is water. And so the type of solution system that is it's solute solvent when it's listed. So the solid, meaning the lemonade powder, is the solute, and then water is the liquid because it's the solvent. Another example of a solid liquid salt solution system is sugar water. So sugar is the solute, it's a solid, and then water is the solvent, it's a liquid. The third one, NiCl2 with an AQ after it, every time you see AQ in parentheses, that means it's an aqueous solution. And when it's an aqueous solution, that means that water is the solvent. And so if water is a solvent, that's a liquid. And then NiCl2 is what's being dissolved in the water. So NiCl2 is the solute, and that's a solid. So this is also a solid liquid. Ocean water is a gas liquid solution system because there's a lot of water in the ocean, obviously. And so the solvent then is water. But what's in the ocean? Carbon dioxide, oxygen, other gases. And so that's an example of a gas liquid because the carbon dioxide and the water are basically dissolved in the ocean water. An example of a solid-solid system is a chocolate chip cookie because you have your chocolate chips basically embedded or dissolved in your cookie dough. So since both of those are solids, you call those a solid-solid solution. Same thing with steel. Steel is a mixture of zinc and iron. And so in steel, iron is the main component. So we consider that the solvent. And then zinc is then embedded into or mixed in to the iron. So that's also a solid-solid solution. And then your last solution system is air. Air is the mixture of oxygen and nitrogen. And since nitrogen makes up most of air, it is considered the solvent. And then oxygen is considered the solute. And so that is a gas-gas solution system because both of those are gases. So solutions are all homogeneous mixtures, and so that means that you can't see the layers, and so they're all stable. There's different types of solutions. So there is an ionic solution, which is basically an aqueous solution. So anything that dissolves in water is going to be ionic, and anything that is covalent, meaning it has two nonmetals, does not dissolve easily in water. So if it does dissolve easily, that's called miscible. So water, salt, water, and sugar, those are miscible. But if they don't dissolve in each other, they don't mix, then that's called immiscible. Like dissolves like. That means that polar compounds will dissolve other polar compounds. So water is polar, so water will dissolve anything else that is polar, but it will not dissolve anything that is nonpolar. Excuse me. Nonpolar will dissolve nonpolar, but nonpolar and polar do not mix. So polar and polar mix, meaning they are miscible. Nonpolar and nonpolar mix, they are also miscible, but nonpolar and polar will not mix. So they are immiscible. So, will they dissolve in each other? NaCl is ionic and it's polar, and water is polar. So, will they dissolve in each other? Yes, because they are both polar. Water and oil. Water is polar, oil is nonpolar. Will they mix? No, because they are not the same polarity. One's polar, one's nonpolar. Oil and gasoline. Will they mix? Yes, because they are both nonpolar. Then we have electrolytes versus non-electrolytes. An electrolyte is basically just something that will conduct electricity. So anything that is ionic compound. So a metal and a non-metal. And that makes sense because all metals conduct electricity. So if there is a metal in your substance, then you know it's an electrolyte. So sodium chloride, hydrogen monochloride, nickel 2 chloride, any of those things will conduct electricity. It's considered an electrolyte. A non electrolyte is something that will not conduct electricity. So, generally, anything that's molecular, anything that is covalent, sugar, a big molecule, oil, rubbing alcohol, gasoline, all very big molecules. So, when you put those in water, they are not going to conduct electricity. Some properties of solutions. So, these are going to determine how well your substance will dissolve. So, the three ways that you can dissolve a substance faster includes stirring, increasing the temperature, and then increasing the surface area, which is another word for size of the particles. So, if you place sugar into a glass of iced tea, or hot tea, I guess, is the sugar going to dissolve by itself? If you don't do anything to the iced tea, is the sugar going to dissolve? No, it's generally going to fall down to the bottom. So if you stir your tea and your sugar, then the sugar is going to dissolve in your water because then the tea is continuously touching the sugar. Whereas if you don't stir, it's just sitting there. So stirring the solution is one of the ways that you can increase the dissolving of your solute. Another thing you could do to increase the dissolving of your solute is to increase the temperature. So hot versus cold. So there's your iced tea versus your hot tea. So at a high temperature, you have high kinetic energy. And if you have high kinetic energy, that means your particles are moving faster, which means they're going to dissolve faster. So if you want to make something dissolve faster, heat it up. Increase the temperature. You're going to increase the kinetic energy by doing that, and that makes it dissolve faster. The other way you could dissolve something faster is to use a larger surface area. Now, this may seem counterintuitive because you're like, well, a sugar cube is bigger than a piece of sugar. Yes, it is. However, when you put sugar in your tea, the only parts of the sugar that are touching the tea are the blocks, the edges of those sugar cubes, not the sugar that's inside the cube. So if you crush that sugar cube up into smaller sugar granules, then all the little sugar granules are going to be touching the tea instead of just the sides of the sugar cube. So if you break it up, it's a lot easier to dissolve than if you kept it as one big piece. So basically, the greater the surface area or the greater the size, the easier it is to dissolve. One last thing that I want to talk about here is solubility. So, solubility is discussing how well something will dissolve. And so, there's something called a solubility limit. Once you go over that limit, no more of the substance will dissolve. So there is a solubility limit. And that's what this graph shows here. This graph is showing you what the solubility limits of each of these substances are at different temperatures. So, for example, if you're looking at NaCl here at 10 degrees Celsius, NaCl, you can dissolve about 35, maybe 35 grams of salt in water at 10 degrees Celsius. But you notice again, as you increase the temperature, so over here to 100 degrees Celsius, now I can dissolve 40 grams of sugar or salt, I'm sorry. And you notice that there is a much steeper curve with some of the other substances. So if I'm looking at KClO3 here, at 10 degrees Celsius, I can dissolve about 5 grams. But at 100 degrees Celsius, I can dissolve about 58, 59 grams. So again, those are the solubility limits. If you try to go over that, you cannot dissolve anymore. So, three different types of solutions. You have a saturated solution. A saturated solution is when you are at the solubility limit. So, you have dissolved the maximum amount that you are going to dissolve. You cannot dissolve anymore. So, that's like baby bear's porridge. It's just right. Unsaturated solution is where you can add more solute to be dissolved. So that's like mama bear's porridge. It's too cold. So you haven't added enough. And then a supersaturated solution is like papa bear's porridge. It's too hot. So you have added too much solute. So you cannot add any more than you already have because once you do that, no more is going to dissolve. It's just going to sit there. So you have a saturated solution, which is perfect. You have the unsaturated solution, which means that you can dissolve more. And then you have your supersaturated solution, which means you've added too much. And so there's an example. So you have your unsaturated solution, you can keep adding more. You have your saturated solution in the middle. So you were at the perfect spot. And then supersaturated solution is where you've added too much. And that's actually where I'm going to stop for today. So I hope you guys enjoyed this very quick notes about